Okay. So today we're going to be reviewing the duality of IP routes. There are two different kinds of routes, kind of like the duality of electromagnetic radiation. When you look at light, it has some properties that are a bit like electricity and some that are like magnetic. Our student learning objectives today, the CSC 243 student will be able to explain what routing is and why it's important, distinguish between dynamic and static routes, recite specifics of protocols used for dynamic routing, provide a case, a caveat, and basic format for static routes, specify the essential components for a simple routing solution, and relate specific criteria for a successful static routing solution. So without further ado, let's take a look at our first objective. Let's explain what routing is and why it's important. Without routing, you might wonder if we already have a table in memory of all the MAC addresses on a local network, what's the problem with just connecting the next local area network and adding its MAC address table to the one that exists, and just have one very large MAC address table? Well, they've actually tried this, and it doesn't end well. When you have 4 billion devices and they each possess a 42-bit MAC address, it's too large and it's too unwieldy and it doesn't work right. A more practical matter is that local area network, client on a local area network has no way to pass an IP packet beyond the broadcast limit. Remember that local area networks exist in the within broadcast limitations. So for Wi-Fi or for Ethernet, it's really only a couple of 100 feet. And even if you chain Ethernet switches together, there's really not much of a limit. So you have this this essential limit. Give me 1 second here so we can update the participant list. Just want to capture others. Good afternoon. So at its core, a basic router performs just two functions. It looks at a packet and determines local or not local. That's the first thing it does. And then it makes a decision. If the packet is local, then nothing happens to the packet, it's dropped. But if the packet is not local, meaning packet doesn't belong on the local area network, this is a very fast binary decision based on the subnet mask. It looks at the network ID and it says, oh, this belongs to our network. Oh, this doesn't belong to our network. If it's not local, then it performs what we call RNR. There's a route lookup and it relays the packet out. So it takes action if the packet is not local. But the first thing it does is it looks at it and says, is this local or not local? And only if it's not local, then it takes an extra step, 2 steps. If you want to put this another way, routes between networks is equal to inter-networks. It's literally the glue that makes the network possible. And we've only touched on routes in related references, but today we're taking the deep dive on routes. We're going to distinguish between dynamic and static routes. That's our next learning objective. But first, let's ask, does anybody have any questions about what we've presented so far?
No questions so far.
Okay. So what we want to do now is distinguish between the two the two very different natures of routes. So you have this dynamic route versus a static route. And essentially, we've been talking about the origins of the internet and how the Cold War and the nuclear weapons race resulted in some research called DARPA. And they wanted something that would be really resilient for a network. So basically, dynamic routes, when you create a dynamic route, those dynamic routes are temporary, they're fluid, they change as network conditions vary. The delivery path can be different every time, and it's guaranteed delivery. So the idea there is you have multiple paths, different paths, and it's always changing so that you can guarantee delivery of the separate packets. So this provides for multipath delivery. Public transport, basically. So one of the signature characteristics of dynamic routes is that you find these on public networks. Good afternoon, Lance. How are you? Good afternoon, Lance. How are you?
Good afternoon. I'm good.
We're going to go ahead and take a quick look at a separate video here, just to, let's see. Being a bit stubborn.
And a packet travels one place to another on the
Can everybody hear the audio?
Yes.
Yes, it's clear.
Okay.
internet, a lot like how you might get from one place to another in a car. Depending on traffic congestion or road conditions, you might choose or be forced to take a different route to get to the same place each time you travel. And just as you can transport all sorts of stuff inside a car, many kinds of digital information can be sent with IP packets.
Here, this is actually Vinton Cerf, one of the gentlemen that's credited with the creation of the internet. Vint Cerf was one of the first pioneers, and basically he's featured in this video. It's actually a pretty good video. We're going to embed this in the addendum of our study guide. It's just a quick and entertaining explanation of this particular aspect of dynamic routes. It's really all we wanted to show out of this, though. Good afternoon, Robert.
Good afternoon.
Okay. We're going to continue on. So essentially, dynamic means changing, fluid. Think of the way fluid flows around obstacles. You have a different path every time. So that's good and bad for reasons we'll talk about more in just a minute. Static routes. Let's contrast this with static. So a static route is established as an anchor that doesn't vary. It's more like stone. So it's a solid, it's unchanging. The delivery path is identical each time instead of being different each time. And it's a guaranteed route, not guaranteed delivery, but a guaranteed route. And it provides for a custom dedicated path where you can apply filters. So you have maintenance and support functions for the IT staff, the technology staff at an organization. They have to support and maintain the network. And so what you're doing is you're structuring that network in a very well-defined way. It's typically used for private transport. So this is kind of like the Dr. Jekyll and Mr. Hyde. This is the stable, consistent. You always see what you get. And then this is the wild card, wild man kind of scenario where everything flows every which way but loose. Any questions so far about the distinctions between dynamic versus static routes? Why should you care? I want to take a moment to talk to you as computer science students. You develop network applications. You may get hired by a company like Cisco or Netgear or Linksys or VIA. You may create network specific applications, or you may create applications that have to account for network delivery. In some cases where you have high security environments or you have large supercomputing data sets, you may need to specify a given mode of delivery, right? And another reason you should care is that almost any connected device, this is something most people don't realize, you can design software to take advantage of the native ability of a device or a system to create a route. You can create a static route. You can also disable or remove or delete a static route. So, but in any case, most people don't realize you can create a static route with a Windows 10 laptop or a MacBook or a tablet. And that's good and bad for reasons we'll get into in a little bit. It's time for a quick review. So we've covered some material, and what we want to do is make sure everybody gets a chance to respond to some questions. And so what I'm going to do is display the question, and then I'm going to stop sharing. And what I'd like you to do is to pull up your chat feature. I want you to use chat, and instead of chatting to everyone, I want you to answer the question as quickly as you can, specifically to me. So I want you to pull my name up in the list, and I want you to chat back an answer to the question that's displayed on the screen. There's a log that shows who's posting which chats, and I will post additional credit for the student that responds first with the correct answer. So occasionally we're going to do this and ask you to chat an answer. For now, we want you to chat it directly to me. Does everybody understand? You're not going to chat back to everybody. We'll do that at the end of the class. Is everybody with me? Everybody ready?
Yes.
Okay. So, what does routing provide to LAN users? What does routing provide to LAN users? Now, I've stopped sharing basically because I want to gauge people's answers separately from, actually, I can go ahead and share. I'm going to share my PowerPoint. You should not be able to see my chat window. Is that correct?
Correct.
Okay. If you've been following along with our presentation, we just said that if you're on a LAN cannot do a certain thing. What does a route provide a LAN? Okay, we have one student that's responded, and the answer is close. The answer is the ability to send data between devices. But that's also true for devices on the same LAN. They can already do that. LAN users can already communicate with other devices on the same local area network within the same broadcast domain. What does routing enable LAN users to do? I'll drop another hint with packets specifically. Without routes, where do packets go? Okay, we're not getting the kind of responses we need. Essentially, we just explained that without routes, packets can only exist within the same broadcast domain. You have the ability to send, okay, somebody just posted an answer, and it is the correct answer. You have the ability to send network packets to another network. Thank you. Okay. So that's the answer for our first question. Next question. How is a dynamic route different from a static route? Just some quick information. Give me one way. Let's just say everybody can respond with one set of criteria for how a dynamic route differs from a static route. You can answer by typing, a dynamic route does this, a static route does that. A dynamic route uses this, a static route uses that. Go ahead and chat your answer directly to me, please. Okay, we're still waiting for someone to respond with an answer in chat. Okay, we have a winner. A student has responded. A dynamic route provides multipath delivery. A static guarantees the delivery path route. That is correct. So one guarantees delivery, the other one guarantees consistent route. Okay, very good. Well, let's continue. All right, in our next learning objective, we're going to recite specific protocols used for dynamic routing. This reference, S544, is basically a reference to the slides provided by the textbook author. This is slide number 544. So what we're going to do here is shift a gear quickly. Let's see, do we have everybody on our, yeah, we have everybody here. I don't need to update this. I'm going to stop sharing and share the whole screen again. Can everybody see this screen?
Yes.
Okay. So in the Blackboard module 3 in the references folder, there's the final version of the study guide for module 3, version 2, and the study guide addendum, and the student slides that the authors provided. This is slide 544. So routing information protocol, or RIP. When you're working dynamic routes, routers use a protocol to automatically determine a best route. And you see here that one of the characteristics of RIP, as it's commonly referred to, is that it considers a hop count. And in a slide that we're going to have in just a, well, all right, I'll go ahead and pull this forward. So if you have a packet that's traveling from router 5 to router 2, RIP is going to say, okay, if I go from router 5, R5, here to router 4, and then to router 3, and then to router 2, that's going to take 2 hops. But if I take another route, like from 5 to 4 to 6 to 3 to 1 to 2, that's an alternate route. So RIP is going to basically calculate different flavors or versions or variations of the connections. So another variation here. Can anyone think of another variation of a route that could go from 5 to 2? Would anyone care to volunteer an alternate route?
5 to 4 to 3 to 1 and 2.
Yes, thank you. Was that Robert?
No, Shamir.
Oh, Shamir, excellent. Thank you, Shamir. Okay, so 5 to 4, 4 to 3, 3 to 1, and 1 to 2. Now, which one has the least number of hops? Well, the one we called out first, right? The direct path. Sometimes, and we're going to talk about errors in a second, but sometimes you'll have more congestion or you'll have other issues, so it has to calculate different routes. So in terms of the transport layer, RIP happens using UDP instead of TCP, and it does make use of CIDR prefixes, and it is most efficient at defining what's called a default route. So once a default route is determined, then that it propagates or shares that route with adjacent routers, and it doesn't matter if you're doesn't matter how many different routers are adjacent. The latest version, there were a lot of improvements with RIP2. Some of the early internet crashes resulted from design flaws in the first version of RIP, and RIP2 improved that. There is a new version of RIP called RIP NG, next generation, was defined so RIP was originally defined by vendors, and so you started running into some issues with RIP in terms of how different equipment brands would calculate and work RIP. The next generation RFC 20, the request for comments that was put out by the IETF 2080 defines RIP NG that adds IPv6 functionality to this protocol. Any questions about RIP before we move beyond RIP? So when you're working with dynamic routing and you have to calculate dynamically changing routes, remember routing information protocol. Another primary protocol that's used in conjunction with RIP is Open Shortest Path First, OSPF, and in response to the cacophony or craziness of different manufacturer brands and versions of RIP, the international standards organizations, the IEEE and the IETF said, hey, we got to come up with an open standard. They developed Open Shortest Path First protocol. So it works with RIP. Let's see. So a link state algorithm, one of the things that distinguishes OSPF from RIP is that the algorithm takes into account the link state of adjacent routers. And one thing that happens on the internet is that sometimes you'll have outages. You know, in our region, you have outages all the time. You have power outages and internet service outages. And one improvement of OSPF over RIP is that it accounts for which routers are actually active and connected. It can import routes from other protocols. Bordergate protocol is a protocol for routing that's associated with redundant routers. So if you have something out here near the internet and you have two internet service providers, you'd have BGP working, and each of them can advertise routes on the different service providers' networks. And so one good thing about OSPF is that when you send a packet out, it could be that one internet service provider with redundant service providers could be shorter to a final destination than the path out on the other internet service provider. So BGP is kind of a rare case. It's something that's used along with RIP when you have more than one connection to the internet. And it's kind of, since it's a special case, we weren't going to cover that today, but it is on the slide, and it is one of the related routing protocols. Any questions? Any questions so far? So OSPF takes into account geographic regions. So if you have a very large network, like a global network, it'll break that down into areas. There is a mechanism for authentication. So basically it helps to, in simple terms, OSPF helps define and identify the active shortest path where routes are concerned. Where RIP calculates all the paths. So when we talk about defining and claiming the shortest path, that's actually the job of OSPF, where RIP creates tables of all the routes. So that's one distinction between those two protocols. So if you want a table of all the routes, you're talking about RIP. If you want an answer for what the shortest route is, that's OSPF. Any questions about RIP versus OSPF?
No.
Okay. So just to recap, one other thing that Comer mentions, RIP works, these protocols work on layer 5 if you're using the internet protocol stack, or layer 7 if you're using the OSI model. So if you're using the internet model, it's layer 5, application layer, both application layer. So for some people, for network engineers, that's layer 5. For computer scientists and researchers, that's layer 7. We mentioned RFC 2080 for IPv6 compatibility. That's important. So what can you anticipate in the upcoming assessment? Well, there might be a question about, well, which version or which protocol is specified for IPv6 for dynamic routing. You'd say, oh, that's RIP-NG, right? Open shortest path first by the IETF, that's an open standard. All the routes for RIP, shortest route for OSPF. Problems. Okay, so we want to basically switch back. You have problems with these two protocols and with dynamic protocols. Basically, when you look at the wide range and variety of complications that occur with dynamic routing, if you want a concise and condensed explanation for what happens most often, the fewest hops are not always the best because of congestion and loops. So essentially, oops, let's go back to this. Now there was another protocol. It's not as common. I don't think it's worth covering. ISIS. It's hasn't really gotten as much play as OSPF, and it's not as common. Routing problems. So multipath routing is difficult. You can have different types of physical layer issues. So if you have two Ethernet hops versus a satellite hop, the dynamics are different. And a lot of dynamic routing doesn't account for the physical layer, the backend differences, the latency, and so on. Basically, routing and congestion isn't straightforward, and it happens on the fly. So you can have this issue called route flapping that crops up. Basically loops. So a packet can start looking for path, and then because of the congestion, it starts to take another path, and eventually it ends up working its way all the way around. You can have all sorts of cute but irritating occurrences. This is one reason why the internet backbone will occasionally crash depending on the kinds of congestion and traffic. And hackers understand this. They take advantage of this. And in particular with routers that are out of date and the firmware hasn't been updated, a lot of these issues are actually vulnerabilities that are exploited. You have this case where, you know, a packet gets out onto the internet and starts bouncing around, and it never really finds its way. We call that the black hole. So yeah, oscillating routes, meaning you have routes that shift back and forth depending on, this is during a large transmission in particular, you have the route changing, shifting back and forth. So route oscillation can cause delivery problems. Basically, if a data file doesn't make it the whole way, it's retransmitted. So that's one reason why internet stuff is a lot slower than local networking. Any other questions before we? So this mentions routing overhead. If you have an older version of a router, a less capable router, depending on the kinds of routes that are advertised and the frequency of RIP updates, it may struggle to keep up. So overhead means it's slow due to the load because of the changing patterns. In any case, this is part of the range of issues. What are the ones I need you to remember? I need you to remember congestion and loops. The other issues happen from time to time, but congestion and loops are by far the two most common routing problems out on the internet. That's with dynamic. Any questions before we go on to the next objective?
No questions.
No questions.
Okay. So in our next objective, we want you to provide a case, a caveat, and a basic format for use of a static route. Can everyone see my screen?
Yes.
Yeah.
Okay. So there are cases when static routes are best, even though they're manual and they're fixed. If you have a structured internal network when total capacity and use is known. So what do I mean? There's two sides of a coin. You have the capacity of the network and you have the number of users. And if you do the math and you find out, okay, the maximum usage fits our capacity, then the use of a static route is ideal because you have a well-defined situation. When you have a well-defined network use scenario, then a static route is usually the best to do. That's also because you can structure, there are plenty of times where IT departments intentionally need to configure the network flow in a certain manner. In particular, they want to combine some of the network flows at certain points or along certain paths so that they can apply security equipment like firewalls and spam filters, intrusion detection systems. So there are specific cases. If you want an internal local network where you have combinations of local area networks that work very, very efficiently with each other. Basically, when you have multiple VLANs, virtual LANs, you may recall from our last module that you ideally want to have different subnets for different pools of users. Usually static routes are best internal to an organization. When do you want to avoid the use of static routes? We mentioned that almost any device or system can use a static route, but that's not the best use. In fact, it can create all sorts of issues. That's primarily because client devices or systems have a nasty habit of moving from one network to another. What I mean by that is, if you have a device or a system that isn't going to move, and let's say it's a printer, you have a large work group printer and it's actually a photocopy machine, it's a network device, it's not going anywhere, you need a forklift to move this thing. That's an ideal case for a static route. If that helps solve a problem with connectivity, for most client devices and systems that move from one network to another, the problem is that the gateway and the network IDs change. And if you define a static route, the static route is, well, it's executed every time you turn on the computer or device. And so if you're on the Wi-Fi at home and you're working with a 192.168.0.0 subnet in your home Wi-Fi network, and you go to your friend's house, they may have a different brand of wireless router. All of a sudden you're on 192.168.1.0. Those are two different networks. Any static routes you created for this network will not work at your friend's condo, right? Or at campus, where we use a public network address range, 146.226. It's totally different. It's public Class B address range. Any questions about when static routes are best avoided? The key here is the word move. Going once, going twice. Okay, the basic format for a static route is actually very simple to implement. And the best way to do this or learn this is to practice it, but it helps to work some simple orientation here. So the basic format has three simple pieces, three easy pieces. The first is the command IP route, and there's a space there. So that's the first part of the command. Second part of the command includes an expression for the network ID, including this. Remember, that includes the subnet mask. So that's in dotted decimal form. You can't use CIDR for that. Not really sure why they haven't updated that, but traditionally you have to state 255.255.255.0 for a /24. And then the third piece is, so the first is the command IP route. The second is the network ID. The route connects. So you have a network out here you can't reach. This network ID is what's the second piece of it. And then the router interface, the third component of that command, is the router interface, the IP address of the router that's along the path to that network. So this network has a router. There's an interface on that router. We'll show you an example of that in just a moment. So the entire command together would look like this: IP route, and here's the network ID all together. There's a space there in between, so it looks kind of strung together. And then here's the interface of the router that connects to this network. So you're going to establish a route to this network, and here's the interface on the router that connects to this network. We're going to give you an example of this. So what I'd like to do is hop out to, I want to create a route to, can everyone see the screen?
Yes.
Yes.
Okay.
This network. So this router wants to create a route so it knows how to get to.
So on the left-hand side, we have a network 192.168.9.0. And on the right side of this diagram behind the CLI screen is a 172.16, two totally different networks. And you have a PC down here. You'll see the screen in just a minute. But basically you want to create this route.
The 172.16.9 over here. So I'm going to create that route by saying IP route. And I'm going to put 172. I'll identify the network here. .9.0. Got to put in the subnet mask, only this time you have to do it dotted decimal style. You can't use CIDR notation, go figure. And then I'm going to put the IP address that the interface on this side uses to access this network. So if this router is passing traffic out to 172, it has to hit this interface first, which is 10.10.9.2. That's where we're going. So I'm going to put 10.10.9.2.
Did everybody see how we traced along the path and then found the interface for that router? So basically, a lot of it has to do with the way you structure your diagram. I'd like to get on to the next objective. Are there any questions about what we just saw?
No questions.
Okay. So, quick review. If you could, pull up your chat and respond in the chat. The chat's open. I'm going to share my screen for only the PowerPoint. Okay, if you can, as quickly as you can, respond to these two questions. Give 2 examples of dynamic routing protocols. Go ahead and put your answer in chat. Once again, chat is logged. We'll see who posts the first correct answer. What are some known challenges with dynamic routing? Some common examples of that. Okay, we have some answers. OSPF and RIP is the first question. Some known challenges. Do we have an answer for known challenges? Okay, in the interest of time, shortest path is not always the most efficient. Oh, black hole, yes. Somebody posted black hole, loops, and congestion, right? Okay, when is use of a static route best? When you need to define the structure of a network. What's a common exception for static routes? You don't want to use static routes for what type of connected systems? Yes. You don't want to, devices that move to different networks is when you don't want to use a static route. Yes, that's correct. Okay. Let's stop sharing and share the whole screen now. We want to specify the essential components for a simple routing solution. Basically, we're going to return to the live solution video in just a moment. But what it'll show is that each LAN must have at least one switch or hub. You have to have a router or a gateway device for each network. The router has to have enough interfaces to link to the other networks. The clients that operate on each, you have to have an active client so you can test for the configuration. And you have to have connections between the correct interfaces. So
And what we want to do is turn them up so that they stay up. And
So you have two networks, one that's defined here, one that's defined there. You have a network in between the two routers. So you have a network that connects all the routers together, but you have separate LANs, 192.168.9 and a 172.16. You have interfaces on the router, both for the local area network and for the connection to the other router. So the router has to have more than one interface, or it doesn't work. You have to have connections between these two. And one thing that's very important to understand is that routers were designed at a time where internet connections were very expensive. For this reason, router interfaces have a nasty habit of disabling themselves and shutting down unless you issue a command called no shut. We'll talk about that briefly in a minute. But what you're going to do is, for your solution, is you're going to open up a new packet tracer solution, and you'll drag the PCs, the two switches, and the two routers, and then you'll config each one of these as shown. Let's go ahead and step back here. Can everyone see my screen?
Yes.
Yeah.
Yes.
Okay, so for legacy reasons, routers shut down interfaces to reduce cost. That means you have to use a no shut command. Basically, novice network staff forget to write changes to memory. So another thing that happens is that even if people remember to use the no shut command, you'll start developing your solution. You'll include the routes. It won't work. Why? Because the connection, the link between the two has powered off. That's where the no shut command comes in. It's a best practice to stop between changes and test, and you use the right command if good. But if you happen to make a change and you test for it and it's a bad change, then all you have to do is reboot the router. So there's a best practice that people in networking practice, not to sound redundant, but it's a habit they have where they stop and they test after they make a change. And if it's good, then they use the right command, WR, and that saves it. If the system powers off and powers back on again, everything you did is lost. So if you make a change and you test for it and it's wrong, they just reboot it. And that undoes the command. It's kind of convenient if you really hose a system. So at this point, what we want to do is conduct a quick review with the time remaining. Let's go ahead and fire up chat again, if you would. So one last round of chat. I'll go ahead and share only the screen. So if you can, let's have everyone respond. What are the minimum equipment components for a routing solution? If you would, in your chat window, go ahead and type in some of the minimum requirements for a solution. Okay. Yes, each LAN must have a switch. You need clients for testing purposes. And each LAN must have a router. Each router must have more than one interface to connect to more than one network. You have to have connections between. Any questions about minimum equipment?
No.
Okay, how must a routing interface be configured to ensure function? There's a specific command It's a very plain 2-word combo. First person to respond gets the gold star for today. What's the command to keep the routing interface configured? No shut is correct. Yes. Keep it running. What's the last part of a route command? So there's 3 parts to a route command. What does it point to? That would be another way to ask the question. What does the last part of a route command point to? The interface address where the network route is stored. Yes, good answer. And give the last step required to preserve the final configuration. Anyone? Anyone? You want to preserve the changes and commands you've made. Right command is correct. Okay. Does anyone have any questions about the material we've reviewed? In Blackboard, you'll see links to all the stuff that you need to start off with your solution. And basically the concepts we covered today should provide the background you need to make quick work of that. I'll remain available as needed for assistance. Does anyone have any questions about the material we covered today? Does anyone? Oh, we have, I do want to mention this. You should have received a notice from Blackboard. There are 2 smaller assignments based on the material we covered earlier this week on Monday and last Friday. Those are due by the start of class on Friday. So we have 2 quick assignments in Blackboard that are due at the start of class on Friday. Does anyone have any questions before we close out today?
No question.
Questions?
No questions.
Okay, I'm going to go ahead and